Good day and welcome to my physics class. My name is NC Joshua. Today we'll be looking at one of the properties of wave, sound wave in particular, which is reflection. Remember, waves can be reflected, waves can be refracted, wave can be diffracted, wave can interfere, wave can be polarized. What are all of these? All of these are properties and characteristics of wave. Also, sound as a wave can be reflected. Sound as a wave can be refracted. Sound as a wave can be diffracted. Sound can interfere, but sound cannot be polarized. Why? Because only transverse waves can be polarized. Sound wave is an example of a longitudinal wave, and longitudinal wave cannot be polarized. But light wave can be polarized because light wave is a transverse wave. Now remember, what is reflection? Reflection is a send back. So if there is a bounce back of wave sound back to you, which originates it, it means that that is reflection. What is refraction? It's a change in the speed of a sound wave, a change in the speed of a sound wave when it moves from one medium to another medium. What is diffraction? It is the spreading of sound wave over an opening. You see something like this. You see something like this. There is a small opening. This is the opening. Then sound waves, sound wave spreads behind the opening. So the sound wave spreads. So the ability for sound wave to spread over an opening is called diffraction. Another way you can define diffraction is the bending of wave around an obstacle. For instance, you are in your room playing the music and someone else outside your room could hear the sound of your music without seeing you who is in the room playing the music. It means that sound could come out through openings and travel through obstacles to where the listener, which is out or who is outside, could hear the sound of the music. That means that sound could travel through corners, so you could hear the music even without seeing the person who is in the room playing the music. So that is diffraction. So it means diffraction can be the spreading of wave over an opening. Diffraction can also be the bending of wave around an obstacle. UTME asks a question. We hear through corners, but we don't see through corners. I reiterate, we hear through corners, but we don't see through corners. What property of wave is that? Hearing through corners means that the sound could bend through corners, but you could not see through corners. That means that is an example of diffraction. But what about uh, 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 polarization? I've said that sound cannot be polarized, but light can be polarized. Now we'll be looking at echo as a topic in reflection of sound. When sound travels and bounces back to the person, it means that it's a form of reflection of sound, which is called echo. So a reflection of sound wave when it hits an obstacle or hits a boundary and returns back is called echo. Now imagine a boy standing in front of a wall or a cliff and he shouts. The voice travels towards the cliff and hits the cliff and returns back to the boy. Now remember, the distance it traveled is assumed to be x. Then the same distance it returns back is x. So I will say that the total distance is equals 2x, which is x plus x. That's the total distance. Now recall that speed, recall that speed is equals distance over time, over time. Therefore, speed, which is v, is equal to, what's our distance? 2x over t. Now remember, I can still do some comparison of formulas here. Recall that V equals F lambda. So I will still say that therefore In place of v, I'll put f lambda is equals 2x over t. I can still go on and on to say, recall again that f is equals 1 over t. So therefore, I can say, therefore, in place of f, I have 1 over t times lambda is equals 2x over t. So therefore, x over t is equals 2x over t. This was a UTME question where we were asked to find a relationship between these parameters as regards in echo. Now, if I have this as a case scenario for echo, what about when the boy stands between two cliffs? When the boy stands between two cliffs, the boy is now between two cliffs. Now it means that if he shouts, sound will travel to this cliff and return back to the boy. Let's assume this is X. Definitely this will be X also. And he travels to this point. This is Y and returns back again. This will also be Y. Now remember that the distance between the two cliffs, the distance between the two cliffs will definitely be X plus Y. That's the distance between the two cliffs. Now I will say our first echo, let's use X for our first echo. Now remember, this boy is not standing at the center. He is standing closer to one of the cliffs. So the position from one to the cliff is not the same as the position from him to the other cliff. So that's why he will hear two distinct echo at different times. So now for the first echo, let's assume V is equal to 2x over t. This for the first echo. What about the second echo? The second echo here is V is equal to 2y over t. That's the second echo. Now it means if I add these two equations together, so it means I'll be having V is equal to 2x plus 2y over what now? Over t. The t I'll be having now is my t1. This is the first time it happened. This is the second time. My t1 plus my t2. So I'll be having 2 open brackets x plus y over t1 plus t2. Now, please take note. Remember, I just told you that the distance between the two cliffs is x plus y. So now we're looking at some examples of reflection of sound, how to calculate questions in this area. Now we have one example. It says, a man clapping his hands at regular interval observes that the echoes of clap coincides with the next clap. If the reflecting cliff is 160 meters away and the speed of sound is 320 meters per second, calculate the frequency of the clap. Now you realize that, let's assume this is the man. This is the man standing, clapping, and he's 160 meters away from a cliff. 160 meters away from a cliff. So the sound would definitely travel in this direction and return back to him. So because he was clapping at regular interval, so there was some interference of the clap. So how can we solve this? Speed of sound is equal to 2x over t. What's the speed of sound? The speed of sound is given as 320. So 320 is equal to 2. The distance is 160 over t. Remember, we are asked to find frequency, but if I can find the period, I can definitely know the frequency. So now what becomes this? So my t is definitely equals 320 320 over 320, which equals 1. So if our period is 1, frequency is 1 over period. This is the total time taken. So that's our period, which is now 1 over 1, which equals 1x. So the answer to this question is 1x. What did I do? I had to first calculate for my time, my period. Then from there, I could get a frequency. Now look at another example. The example says a man standing between two cliffs, parallel cliffs, fires a rifle. He hears one echo after 1.5 seconds, one after 2.5 seconds, and one after 4 seconds, meaning he is hearing three distinct echoes. Calculate the distance between the two cliffs. Now remember, when I was saying something not quite long in our previous class, I told you that if we have two cliffs and the man is standing between two cliffs, if he fires a rifle, he will hear one will go and return. First echo, this is X, this is X. Another will go to this cliff and return to him. This is Y, this is Y. The winner said the distance between the cliffs is definitely X plus Y. X plus Y is the distance between the cliffs. So if I want to solve this question, if this is the distance between the two cliffs, and I know that V is equal to 2x over t, where x is distance. So because of this case, it becomes V is equal to 2 open bracket x plus y over t. Why? Because the distance between the two cliffs is now x plus y. So if I want to solve this, it becomes what's our speed of sound is 340. So 340 is equals to open bracket x plus y, which is our distance between them, over the time it took to go here and the time it took to come here. So you heard the first one in 1.5 seconds. He heard the second one in 2.5 seconds. So 1.5 seconds plus 2.5 seconds, that becomes 4 seconds. If you check very well, that is the time it took to hear the third echo. So I can solve it from here by now saying, therefore, my x plus my y is equal to 340 times 4 over 2, which will now give us 680 meters. That's 680 meters. I can solve it in another manner. Just watch how I could solve it without using this procedure. Now, I could solve it like this, or this is another alternative way to solve it. Remember, this is the cliff, and these are the cliffs, and this is the man standing who fired the rifle. So if he took here X and returned back X as our first echo, went this cliff, came back to him as our second echo, YY. So I can say V is equal to 2X over T1. That's for this case, which will be equal to 2 bracket x over the time it took, which was 1.5 seconds. It took 1.5 seconds. Now, where my v, which is the speed of sound, is 340. So I will have 340 is equal to 2x over 1.5. So I will now have my x to be equal to 340 times 1.5 over 2. So if you have this, you have this. That will give us 255 meters. So x equals 255 meters. Now, what about y? Let's do that for y. V is equal to 2y over t. Now I have 3, my v is 340 is equal to 2y over, what's the time it took for the second echo? This is 2.5 over 2.5. So therefore, y is equal to 340 times 2.5 over 2. So y will now be equal to 425 meters. Now you now realize that we have known what is x as 255, and we know what is y as 425. Now remember, the distance between the two cliffs is x plus y. So distance between the two cliffs equals x plus y. So that will now be equals our x is 225, which equals 225 plus our 425. The final answer is 618 meters. So that's how you solve a question regarding first echo, second echo, and third echo. Thank you.